In this quick tutorial, I'll show you how to perform the substitution rule with integrals. This is part 1 of the series. The steps for substitution method for indefinite integrals are the following. First, you want to find an appropriate substitution where u is equal to g of x. Next, you want to convert dx to du. Third, you want to substitute in so that the integral is entirely in terms of u and there are no more x's. 4, integrate. This should be easier than before, and if it's not, then you've done something wrong. And then 5th, convert back to original variables. Let me show you with question number 1. Here we will set 2x plus 7 is equal to u. And if I do that, I end up with the following. U to the power of 5 dx. The next thing that I'll do is, since I set u is equal to 2x plus 7, is I will differentiate the right side, and if I do that, I end up with du is equal to 2 dx. Now I just took the power rule of this term and of that term, and it gave me 2 dx. Remember, in the steps stated above, we want to get rid of dx. Now the only way we can get rid of dx is if we isolate for it. Watch, dx is equal to du over 2. Now if we replace dx with du over 2, we have an integral that is in terms of u entirely. What we can do next is find the integral of u to the power of 5, and that's easy to do. U to the power of 5 becomes u to the power of 6 over 6. So we end up 1 over 6. I just separated this. U to the power of 6, 1 over 2 du. I'm going to multiply half and a sixth together, and I get 1 over 12. And I'm going to replace my u back with 2x plus 7. And since this is an indefinite integral, we need to add the plus c at the end. So that is the antiderivative to this function. Let's do another one. This time they want us to find the integral for x to the power of 2 times 5x to the power of 3 minus 1 to the power of 6. So we're going to follow our steps and set something equal to u. The most appropriate substitution in this situation would be to convert this into our u. So we have u is equal to 5x 3 minus 1. The next step is to find the derivative of the right side. And if I do that, I end up with du is equal to, this goes down, this decreases by 1, and this goes to 0. Now don't forget, since it's in terms of x, you should put dx on this side. Next, we want to get rid of all instances of x in our original problem. So we need to somehow isolate for dx where when you apply it back into the function, there are no more x's. And the only way I see that happening is if I divided both sides by 15x squared. If I divide both sides by 15x squared, I end up with dx is equal to that. And I can now apply that to my function where I have x squared u to the power of 6, and I'm going to replace that right here, du over 15x squared. Now the reason why that's ideal is because these two x's will cancel out. And so we're left with a very simple integration problem. U to the power of 6 becomes u to the power of 7 over 7 times 1 over 15. Now don't forget this 15 that was there plus c. So let's go ahead and multiply these two together. 7 times 15 is equal to 105. So I'm just going to continue my work up here. 105. U can now be replaced with 5x to the power of 3 minus 1 plus c. So there you have it. 2 introductory examples on how to perform U-substitution when finding the integrals. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.